Okay, ladies and gentlemen, welcome to the second of what I assume will be 3 videos over section 3 of chapter 2 in your geometry textbook. This video is going to cover the truth value of conditional statements. Just like any other statement, every conditional statement has a truth value. That truth value is either true or false. It is not allowed to be both. So when we talk about a conditional statement, and again that's the statement if P then Q, the truth value of that statement is based on the truth value, the overall truth value of the hypothesis P and the conclusion Q. So if we look at the possible combinations for the truth values of the hypothesis and conclusion, there are only 4 ways that that can play out, which allows us to create this idea of a truth table that will show us every possible outcome, every possible interaction in terms of truth value for the hypothesis and conclusion of our conditional statement. Either both the hypothesis and the conclusion are true, the hypothesis is true and the conclusion is false, the hypothesis is false and the conclusion is true, or both the hypothesis and conclusion are false. These are the only 4 possibilities. There are no other possibilities that exist. It has to be one of these 4. So by filling out this table, we can always look at, well, okay, what's the truth value of the hypothesis? What's the truth value of the conclusion? And we can use that knowledge to tell us definitively what the truth value is for the overall conditional. So here's how this works. If the hypothesis is true and the conclusion is true, that guarantees a true conditional statement, a truth value of true for the overall conditional. If the hypothesis is true and the conclusion is false, like in the second row of this table, that is how we know that a conditional is false. The tricky part is the way that conditionals work. The rule of logic states the following. If your conditional statement is based on a false hypothesis, so if the hypothesis is false, you are not allowed to judge the truth value of the overall statement. You simply have to assume that the statement is true. So these last 2 rows, since P is false, we don't have any choice. We simply have to assume that the overall statement is true, which really is a bothersome thing, but those are the rules of logic. If the hypothesis is false, we are not allowed to judge whether or not the conclusion is true or false, which means that we can't judge whether or not the conditional is true or false. And if we can't prove that it's false, we have to assume that it's true. Those are the rules. So a couple things to notice here. First of all, the only way to show a conditional is false is to show the hypothesis P is true and the conclusion, which is our Q, is false. It's the only way to do it. There's no other way to make that happen. The other observation we should make here is that if P is false, we have no choice. We must assume the overall conditional is true. We do not have any choice in the matter. That's the rule. That's the way that it works. So let's look at some examples of this, and then we'll end this video. Here are 3 conditional statements. We're going to determine the truth value of each of these conditional statements. If it's true, we're going to explain how we know it's true. In other words, we're going to try our best to explain how we know that there are no counterexamples. And if it's false, we're going to provide a counterexample. So number 1 says, if you divide an integer by another integer, which makes our hypothesis, you divide an integer by another integer, then the result is an integer. So there's your conclusion. Now, I do know that we probably aren't all 100% familiar with the word integer. The word integer, or the set of integers, which are indicated with a capital Z with an extra crossbar. The integers are your positive and negative whole numbers, including 0. So this set here is showing the integers. So that's what we mean when we say integers. So when we talk about the overall truth value of a conditional statement, we are not necessarily looking at whether the hypothesis is true or false so much as we're looking to see whether or not the hypothesis is possible. If it's possible, then it's true. So in this first example, it says, you divide an integer by another integer. So the question you have to ask yourself is it possible to divide an integer by an integer? And with the exception of dividing by 0, yes, you can divide any integer by any other integer, which means that P, the hypothesis, is true because it is possible to divide an integer by an integer. Unless you're trying to divide by 0, but that's a whole other thing. The conclusion then says the result is an integer. So when we try to figure out whether the conclusion is true or false, we base that on the hypothesis. So what that's saying is we're taking an integer, we're dividing by another integer, and the result has to be an integer. And hopefully you're sitting there going, no, it doesn't, because you're absolutely right. This is a false conditional statement. See, P is true, but Q is not true based on P. And for a counterexample, we simply need to pick two integers, such as 1 and 3, divide them. 1 divided by 3 is not an integer. That is 0.3 repeating, which is not an integer. That would make 1 divided by 3 a counterexample. I don't know why I said integer. That is a counterexample to the original statement. This is our counterexample. That is enough to show that that is a false statement. Okay, on to the next one. So the second statement reads, if next month is October, then this month is September. Now don't get caught up on whether or not it is currently, what month it currently is. That's not important. Again, what I said was, when you're judging the truth value of a conditional statement, you ask yourself for P, is P possible? Could it possibly be October? Is October a choice? The answer to that is yes. So your hypothesis is true because it could be October. And then based on that, we judge the conclusion. So we say, okay, if it is October, then this month, or if next month is October, then this month is what month? Well, this month would have to be September. So this would be an example of a true statement because October follows November on our calendar. Or I'm sorry, follows September on our calendar. Okay, now this last one is the one that bothers people. See, here's the thing. We go in here and we identify our hypothesis. Our hypothesis is a triangle has 4 sides. Our conclusion is that it is concave. Now here's the thing. You look at that statement and the first thing that pops in your head is that is ridiculous. Of course it's false. Well, if you say that, you are wrong. This statement cannot be judged. It cannot be declared false. We must simply assume that this statement is true. We have no other choice. And our explanation for how we're stating that it's true is the following. If the hypothesis is false, which it is, a triangle cannot have 4 sides, then we cannot judge the conclusion. That is the explanation I would expect to see every single time. We are simply forced to assume that that's the third statement is true. We'll go off to another video here. Thank you for your time. We'll look forward to you watching the next one.